Okay, so um, I've seen a lot of us are still having some challenges on dimension analysis, including vectors, some of the parts. Okay, so now what it is, we are going to start from the first question. I'll start from the first question. Okay, so the first question, the answer was given already, but they just wanted you to have a formula. I mean, the procedures that you can do at that we can use for us to reach on the same answer, not proving if that is dimensionally correct, but you have to find the same formula. So the first question says the wavelength associated with a moving particle depends on its mass, velocity, which is v, and Planck's constant, which is h. So in this case, they're saying h is measured in kg meter squared. So they're saying show dimensionally that lambda, which is for wavelength, is directly proportional to Planck's constant and inversely proportional to mass multiplied by velocity. This question, like I said in the previous videos that I've been posting on YouTube channel, so if the question is trying to tell you to say a certain quantity depends on some of the quantities, what are you supposed to do? This is where now you have to write it like this. You say, so in this case, they're saying the wavelength is directly proportional to Planck's constant. It is also directly proportional to the mass. Then it is also directly proportional to the velocity. So remember, we are solving this system using dimensional analysis. Now, what are we supposed to do? Here, for us to understand it fully, what you are going to do, you have to make sure that the right hand side is having some powers. So this question just required us to do what? It required us to show that wavelength is equal to, so here saying that we have to show that wavelength is it is directly proportional to what? Okay, write it like this, h then over mv. Okay, now how are we going to write that same expressions in a form of dimensional analysis? What you're going to understand is here, first of all, this right hand side, you need to raise it to some powers. For you to remove this, you have to do what? You have to introduce what we call the equal sign. So this is going to be written like this. You say wavelength has to be equal to, going to say k, h, you raise it to power x, you say mass to the power y, then velocity to the power z. Okay, so our main aim is to make sure that we come up with the formula, which is what? Which is the one which is in the middle there. All right, so you're going to understand that for you to come up with this, first of all, you need to know the dimensions for each. But since this is a constant number, or it is just a constant number, what are you going to do? You can ignore this part and focus on the parts that are having what? The dimensions. Clear? Okay. Then what will be the next thing now? I know here, if you write the dimensions for this one, we're going to get what? Length. Write the dimensions for this one. You have been given in the question. They're saying the dimensions for Planck's constant must be what? Kg meters per second, meter square second. Okay, so and then for velocity, we know that the dimensions are supposed to be meters per second. So in this case, we're going to write using dimensions as L t to the power -1. I know this is where we are making a lot of mistakes on the same question. Okay, so once you reach here, what are you supposed to do? You say dimensions. Write dimensions for what? For its quantity. So I'll start with the wavelength. I know that wavelength is measured in what? In meters. Then if you write it in a form of dimensions, you'll find that you're going to have what? Remember to put it inside the square brackets to show that you're writing the dimensions of that same quantity. Okay, we move to Planck's constant, which is h. They're saying h has to be equal to, so since they're saying it is having the units of kg, meter square per second, definitely its dimensions are going to be what? Dimension for mass is m, then length is what? L square. Per second, you're going to write it in this format, say -1. Sorry, I know this is not visible. Let me write it somewhere there. Say m L square t to the power -1, like this. Okay, I think everything now is viewable. All right, so what next are you going to do? You go to mass, the dimensions for what? For mass. The dimensions for mass are supposed to be what? You're going to have kg, which is having what? Capital M. Okay, we proceed to the third quantity, which is velocity. Say velocity has to be equal to meters per second. The dimensions are supposed to be L t to the power -1. Okay, so you're going to understand that, put it like this. All right, now the next thing, now you get back to this formula, which is at this given point, this one, meaning that the dimensions for this you are going to replace with what? L. So I'll write it here by saying L, this has to be equal to, whenever you reach at this given point, you can ignore the k, but on this one, since the dimensions of this are given as those, but remember h here is raised to power of x, you are going to say m L square t to the power -1, you close, then you put the power of Planck's constant, like this. Then you multiply, you can just put a dot, you go to mass, you say the dimensions for mass is supposed to be m, you close, then it is raised to power y, like this. And you say dot, dimensions for what? For velocity is L t power -1. It is raised to power what? Z, if I'm not mistaken. I think everything is now visible. Okay, now what is the next thing, guys, we are supposed to do? Okay, so just a bit, I'll move this paper. Maybe I can move the board itself. Move this board to that given side. So definitely here I'll also write the same things which I'm from writing, so that we should be able. Okay. The problem is we can't see. Okay, so what we're going to do, just do this. Unplug this paper, then attach a new paper. So if you check the last part there, we are saying the dimensions are supposed to be what? The dimensions, in this case, the dimensions are supposed to be L has to be equal to m L square t to the power -1, you close, say x dot m y dot L t to the power negative 1 power z. Okay, so what you're going to understand is every quantity inside the brackets will be raised to power of x. Same applies here. Even this one is going to be raised to power x. And the last part you do likewise. But you see, on the left hand side, we don't have some of the quantities which are found on the right hand side. What does the principle of homogeneity state? So here you follow what? Following the principle of homogeneity. What does the principle of homogeneity state? You know that you can only multiply or divide quantities of the same or different dimensions at inconvenience, and it even goes further up to you have to equate what is on your left hand side has to be equal to what is on your right hand side. Now, since here we don't have some of the quantities on which are found on the right hand side, what are we supposed to do? Suppose, okay, in this case we don't have this one on my left hand side. What am I supposed to do? I have to make sure that I introduce m on my left hand side by equating it to what, or by raising it to power of 0, because it is not there. So that whenever you raise this m to power 0, what you're going to understand is it will be 1. Then 1 multiplied by this, you're going to get the same quantity. Same applies to t. In this case, we have t on my right hand side, but since I don't have t on my left hand side, what am I supposed to do? I have to make sure that I also introduce t and raise it to power 0. So we're going to have something like this now. We're going to have L t to the power 0, m to the power 0. This has to be equal to, okay, so this part, if you check, we are saying each quantity here has to be raised to power x. Okay, and then even there, you need to raise that one to power x. Here you also do likewise. Okay, so I'll write it as follows. I'll say m power x t. So since this and that one are going to multiply each other, I'm going to have 2x. Sorry, this has to be L, sorry, not t. Then you say t to the power negative x dot. Whenever I come that side, you're going to find that it will be m to the power y dot L to the power z, and finally t to the power negative z, because this, whenever you raise it on this side, you're going to get negative z. Okay, now here, what are we supposed to do next? You'll find that there are certain quantities on my right hand side having the same bases but different powers. Following the rules of indices, what are you supposed to do? You pick this thing which is common and raise it to what? To the addition of the two numbers, since you're having the common base. Whenever you're multiplying things or the common base, you add the powers. That's what the rules of indices are saying. So you find that we're going to have, on my right hand side, I will have m to the power x plus y. I also have L to the power 2x plus z. I also have t, which is going to be what? T to the power negative x minus z, because this is minus, that one is also minus. Then on my left hand side, I remember we are having, for this one, you can equate this to what? To m to the power 0, because that's what is found on your left hand side. On your left hand side again, for L, we're saying L to the power 1. Okay, then for t, we're going to say t to the power 0. So quickly just type, what are we supposed to do here where we are now? What are we supposed to do here where we are? Just type quickly, type your response. Are we following, guys? If we are following, just type that I'm following. If you are following, type that you are following. Hello. Okay, so now where we are here, what we're going to do is these that are common, that you can cancel this, you also cancel that. We're going to have the powers only. So this is going to be what? We're going to have x plus y equal to 0. It will be my first equation. The next equation, you say this one again, that one they are common, equate the powers. You're going to have 2x plus z equal to 1. You're going to have the second equation. Then lastly, this one, that one they are common, we're going to equate the powers. We say negative x minus z, it has to be equal to 0. Okay, so I'll just get a rough paper for me to finish up my solvings. So here, this is where I'll write all these three equations. These three equations. Okay, so we have the first equation, which is x plus y equal to 0. We have the second equation, which is 2x plus z equal to 0. Sorry, this has to be equal to 1. And then the last equation, which is negative x minus z equal to 0. So this is my first, second, third equation. Now what are we supposed to do next? We have to solve these equations simultaneously. So you can get this equation and that equation, you solve them simultaneously first. After doing that, then you're going to proceed to the first equation, which is having x and y. The reason why we're trying to solve these two, because they all have x and z. So I'll say solve equation 1 and 2 simultaneously. So find that we're going to have 2x plus z, which is equal to 1, negative x minus z equal to 0. We can just add direct, and then these two, they're going to cancel out. So 2x plus negative x, we're going to have x equal to this plus that one, and to get 1. Mean that the value of x in this case has to be what? Has to be 1. You proceed to the next. So you say, for me to get the value of z, I can use this expression by saying negative x minus z equal to 0, meaning that negative x is equal to z. So since this one, the value of x is 1, mean that z is going to be equal to what? Negative 1. You go to y. Since we are saying x plus y is equal to 0, definitely x plus y equal to 0. This value we have it already, which is 1 plus y equal to 0. And that y is going to be equal to negative 1. Okay, so we are done. Now you get back to the original expression. You get back to the original expression. My original expression in this case is this one. This. So what are you supposed to do now? This is when now we are going to write it by saying, I know the values of x. We are from finding. I say x is equal to 1, y is equal to negative 1, z is equal to negative 1 also. So since if you check on this expression, it is having all those stuff, then you are going to write it like this. You say wavelength, which is lambda, has to be directly proportional to h to the power 1, which is the part of x. And you say m to the power -1. Then you proceed to v to the power -1. So definitely you're going to write it like this now, directly proportional. So since this is just one and the same, like you drop them, we're going to say h multiplied by 1 over m multiplied by 1 over v. Therefore, lambda is directly proportional to Planck's constant over mass multiplied by the velocity. Then you deserve your 5 marks. And that's how we were supposed to answer this question